Hey everyone, I'm Aarav, sitting here with Chetin, who's the founder and CEO of Atlas Robotics. Today we'll be discussing a little bit more about robotics in general, what Atlas Robotics is up to, dive a little bit deeper into the technical side of robotics industry in general, and then move forward with it. So before we continue, Chetin, would you like to introduce yourself?
Well, thank you so much for having me. It's great to be here. I'm Çetin Meriçli, co-founder and CEO at Atlas Robotics. I've been working at the intersection of robotics, artificial intelligence, and machine learning, which is now called these days physical AI, for over 25 years professionally, and close to 40 years as a lifelong pursuit, lifelong fascination with intelligence. Um, and Atlas is it was a physical AI company in the near term, focusing on intralogistics and material handling automation. But our broader goal is to be a generalizable physical AI, embodied AI platform for all types of physical work.
Mhm. So, Chetan, one of the main questions is robotics has a lot of industries, a lot of niche products. What led you to decide on this
Mhm.
specific industry and no other one?
So at the beginning, as I say we, because I'm doing it with my brother as my co-founder. We've been doing a lot of things professionally and personally together for a really long time. When we did our market research and our overall triage of different ideas and different potential markets, we knew that we wanted to do physical AI and generalizable AI, but you always have to start from somewhere. Your landing market needs to be representative enough, commercially relevant enough, and large enough. So we looked at all different potential initial markets, and what you want to do when you are choosing this initial focus is you want to find a large enough market, and that market needs to have a big enough pain point. It's not just like a nuisance, but a front and center big burning platform, a big problem.
Mhm.
And very large markets and very big problems, they they don't go very long without getting addressed. So if you find that gem, that well, there is this large market and there is a huge problem, and it's still unsolved, it only means that this is borderline impossible to solve. So
Yeah.
it should be very, very difficult, and you need to have a an angle. Like you need to first have an understanding of, oh, okay, so this is why this may have come this far without getting solved. Maybe this is what the people, conventional wisdom or common sense got wrong, and this is what we think differently. And this is a thesis. This is a bet that we are going to take, and only after that you should choose that particle vertical. For us, the path to generalizable physical intelligence had to start from somewhere that is a good representative of everything that we will build in the future.
Mhm.
There are a lot of different ways of creating different types of values, but the biggest aggregate amount of value in the physical world can be created with mobile, dexterous manipulation. So just mobility, just being able to move from A to B has value. Just manipulation, you can think of traditional industrial arms that are just mounted on a tabletop. That has some value, but a very synergistic one plus one being more than two type of aggregate value it appears when you can have manipulation and mobility in at the same time. So we looked at logistics, which is one of the largest, if not the largest industry, and we looked at where the cost of operations, if you look at that, but by and large, labor is the top cost, and the big bulk of that labor goes to bulk material handling, which is pelletized good movements, which are done by forklifts. And we try to understand why this is hard to do, and we realize that because forklifts are always in the line of fire, they always interact with the unfiltered world. And that is very difficult. You cannot do it with scripted or old-style industrial automation or old-style robotics. It really requires flexible intelligence. So we said, okay, it's logistics, it's forklifts, and we went one step further. We said pellet jacks. If you know what a pellet jack is, it's the smallest type of forklift. It can lift a pellet only a couple of inches, enough to move it on the horizontal direction.
Yeah.
Because when we did the analysis, we realized that about 80% of all pellet movements are on the horizontal and the ground floor. So this is actually the minimum viable product of a mobile dexterous manipulation, because an autonomous forklift or autonomous pellet jack needs to manipulate. It needs to pick up a pellet, which is a form of dexterous manipulation, albeit very, very like a limited,
Yeah.
needs to do the mobility and needs to drop it off. That's why we basically created that bullseye, created that Venn diagram, and decided to start with intralogistics and with autonomous pellet jacks.
Yeah, that's very interesting. Yeah, I never thought that there are so many like good questions which show up when you're trying to get into the nitty-gritty of like, the smaller things around you. Which actually brings me to the next question. Obviously, the robotics industry is like rising at an incredibly high percentage scale, and I would say like every fifth person I talk to has a robotic startup at this point. And the issue right now is I myself, like we have had a lot of issues about, pivoting every 2 months because there's something or the other like which is coming up different and better. So, a very valid example is 2 months ago, if I started working on an idea and I would say that we are doing data collection, like a day later, we have 50 companies which are already standing over there for data collection. And there are some which have crossed like $300 million Series B funding already, or like Series A funding. How how is Atlas Robotics working towards this? Like, what is the proprietary thing that this company has that other companies don't, and what makes you stand out from your competitors?
Yeah. There are a couple of axes there, but I think first and foremost, the way we approach AI is very different than the rest of the industry. We use, I think the closest, somewhat common term for that is neurosymbolic. We are not uh, banking on just one type of AI tool, not just a very large neural network, not just end-to-end pixels to controls it, or not just old school. Well, here are some rules, here are some just like decision tree, just like follow that. We basically look at the roughly 80 years of AI history and all the little tools that we worked really, really hard to put in that AI toolbox. Now, the latest ones are uh, uh, large models. And we built a framework, a stack that utilizes all of it.
Mhm.
It's basically a tool using agent, and the tools are more symbolic, more deterministic, more algorithmic, more mathematical components. That enables us to basically move towards generalization a lot efficiently, a lot more efficiently, because fundamentally generalization means understanding. And large data plays mean memorization.
Yeah.
It almost never takes binders and binders of the examples of the same thing for you to understand what that is. One, two, three is usually enough. You don't need to look at 8,000 episodes of shoelace, like tying the laces of your shoes to really understand, okay, so this is what it means.
Mhm.
So a biggest problem in today's AI, and we differentiate ourselves orthogonally from that, is the current big models are basically pattern matchers, and they memorize.
Mhm.
They are excellent at capturing and ideating around correlation. In other words, answering the what question.
Yeah.
But generalizability requires you to be able to answer why question. That's where we are doing some proprietary things that enables us to move really fast, be a lot more resilient and a lot more generalizable in the adversarial sides of the real world, and do not require just setting like a lot of money on fire. We use money to grow, not money to just memorize, if you will.
Yeah, yeah. No, that's 100% true. But the recent industry, like what I am seeing for the last couple of months, is that people want to train the robot as much as possible on a specific task all the time. So if I'm grabbing onto an apple using tactile sensors and vision based and like all the other sensors, you want to collect that same repetitive task almost 8,000 times or like 5,000 times to have this sort of like confidence range where the robot, when it goes into the real world, it does not fail. And now a lot of companies are also claiming that, yeah, now we wouldn't need 5,000 tests, we'll need maybe 50, and things will be a lot better. But again, the question that arises from this is that once these are deployed into the real world, how well can the robot actually understand the why behind this problem and,
Mhm.
not fail? That is like the main issue going on. And that's where deployment has been delayed in the robotics industry.
That's one of the factors playing into this lackluster deployments, or things taking too long and being too fragile, too brittle. Fragility and brittleness, it really comes from this inability to generalize, which is down to like you're fine as long as the next scene or the next situation that you are facing looks very similar to what you've seen before, and you basically were able to memorize what needs to happen in that particular situation. So as long as you are within distribution, that's the lingo for that. Especially the newest models are extremely good in interpolating within the known universe, and they are also extremely horrible in extrapolating towards out of distribution, towards the unknown. And if one thing, as you said, if one thing that we can guarantee with the real world is that you don't know what you don't know. The moment you set foot in the real world, you will see things that it was impossible for you to fathom, so that it was impossible for you to create synthetic data or do demonstrations around, etc. So what do you do about that? Well, in fact, you have to treat it as a fundamental requirement from day zero, and you have to build your system for continuous learning, lifelong learning. Another thing, again, the today's AI industry, be it in the generative AI enterprise or robotics, everybody is talking about, oh, we're going to train something. We are training something in our lab. And once we are done training, it is so awesome that it's going to be able to do everything everywhere. No one is talking about the necessity of continuously adapting whatever base training you came up with. We from day zero, we thought that it is imperative to have a mechanism that allows you to continue learning. Because again, as I said, you don't know what you don't know, and every experience at the edge of the world, it contains very valuable information. Why not take advantage of that? So that is that the inability of that, I think, prevents people from deployment so far from really becoming mainstream, because they rarely can go beyond the well-curated pilot conditions that do not really reflect the harsh reality.
Yeah, yeah. Yeah, that makes a lot of sense. I think it is really important to, set bases first before actually getting deployed into the industry. And there are a lot of things behind it that are also, causing all of these problems, which actually brings me on to like a follow-up question. You did mention about synthetic data just like 2 seconds ago. A question related to that is, I've heard there's a massive issue, like, people are using NVIDIA Isaac Sim and like a lot of other like Foxglove and all. Yeah, definitely. But sim to real is a massive issue in the industry, and a lot of
Mhm.
people are saying that, yeah, we are trying to, make a software on top of that that can, ease up the process and stuff. It hasn't worked. People are still facing the same issue. At Atlas, sim to real is probably being used, obviously. And like, how do you, convert that synthetic data into real world scenarios where the robot once actually deployed into like a pilot run without any human interaction, how does it perform?
So we definitely use different types of simulators at different stages of development, but we are not following the more common workflow of we're going to start with all synthetic simulated data. We're going to train everything, and then we're going to put it on the robot, and the robot is going to go to the real field. Our robots went to the real field,
Hmm.
and we basic with this neurosymbolic stack, relying more on the symbolic and more traditional algorithms at the beginning as scaffolds, and we call that day one anti-fragility. So you need to be good enough to survive day one, and you need to be flexible enough to become better for day two, day three, etc. So our overall workflow for deployment has also been a little bit contrarian and unorthodox, if you will. That enables the different type of flywheel, though people have been talking about in the future tense, but I can talk about it in the past tense because we literally have been doing that. If you figure out a way of getting that day one competence and start operating in the real field, and then you start seeing all of these HK's data, and then you can get that capture that experiences, and then use different flavors of simulators to enrich those. Like you see one situation, but then in the simulator you can also create, I don't know, 1,000 variations of that one situation, and that you can test against that, and you can see how you are performing and adjust and adapt as needed, and rinse and repeat. So every time you see something in the real world, being able to process that information, and we also have again unorthodox ways of doing that processing on the robot in the field,
Okay.
not flowing all that data back. We don't think that is practical because most actual industrial places don't have IT infrastructure that enables uh, petaflops of or petabytes of data flowing back, and there's privacy issues. No one wants actual data leaving the premises. So we our AI system actually uses something a lot closer to how humans learn. You experience the world, and then you learn from that experience, and then you can communicate the learned knowledge. Like I worked at a place. I cannot have you see through my eyes the exact raw experience, but I say, hey, like I learned this and that in the warehouse, and be careful because this can happen, that can happen. So all this actual distilled knowledge. This is what we are doing, which enables us to operate in a decentralized fashion, reduces the communication bandwidth needs because you're only communicating high value knowledge. And that's how we are basically getting past that uh, one way, or like a only forward pass sim to real thing. There is no sim to real in our case. There is real, then a real to sim, and then sim back to real, and then real back to sim, and it's a flywheel.
Yeah, yeah, yeah. Yeah, no, that loop is definitely a lot more understandable, and I think it can give out a lot more outputs for one specific scenario in general. Like, you know, if you want the robot to pick up a bottle, it's in real world, it's one bottle, but you can have different scenarios of different type of bottles, different shapes, sizes, colors, whatever. There are a bunch of examples, and I think simulation eases up that process for you rather than actually training the robot all the time in person. Um, and yeah, very interesting. A similar question to that is, I've heard a lot recently where people are like, yeah, we collect egocentric data. Yeah,
Hmm.
One X Robotics is doing teleoperation, one of their robots, which there's someone
Hmm.
working behind the scenes to control it. And people are also hard coding robots like the
Hmm.
S100, they are hard coding it so that the robot actually moves by itself or using egocentric by itself. So what do you think is the future? I know all three of them might give different outputs, but what is the trending one, and why has these three come out all in one go?
Okay, so let's start with that last one very quickly. I think some of those appeared as ways to create data or relay data to the robots is because that's what we had. So this whole egocentric or overall video, there's ample video. You go to YouTube, you go to wherever, there is a lot of video that's not coming from the robots, but that basically shows the real world and humans interacting with the real world. So the idea is that if we are sitting on that much of data, why can't we use that? All the information technically is there, so we just need to find a way of harnessing that. That's I don't agree with the efficacy of that approach, but the fundamental idea is not wrong.
Mhm.
And teleoperation is teleoperation. Like if you can do that, why not do that? And every time you are doing teleoperation, it's an opportunity to consider it a labeled example,
Yeah.
assuming that the human teleoperator is actually and the oracle knows the best. So I think that's how and why it basically started. And going forward, I do think the real breakthrough, not an incremental, let's squeeze a little bit more juice or let's do more of the same, but an actual order of magnitude, two orders of magnitude, three orders of magnitude gains will come from explicit introduction of causality. Again, going back to this fundamental limit, to me, fundamental limitation of today's models, today's AI approaches it's all about correlation.
Yeah.
And again, that's why there is no underlying abstract uh, formula extraction, rule extraction, or what I can call understanding about, this is how you do multiplication. Like there is a very formulaic, there's an algorithm for doing multiplication with two arbitrary numbers.
Mhm.
Well, in day-to-day lives, we also memorize the sub-common ones, right? Like all the single-digit 6 by 8, 9 by 9. You don't always sit down and perform the actual multiplication. You just fetch from the memory. You can memorize it. But we are not trying to calculate the multiplication of two 10-digit numbers from the memory.
Mhm.
We use a calculator, which is a very rudimentary tool. It does only one thing, but it does that with a deterministic success. 100% of the time, it does it right.
Yeah.
So I think going forward, like one aspect is to know when to use explicit knowledge and using tools that can harness explicit knowledge, when to rely on your flexible heuristic estimators, and the explicit capture and explicit representation of causality. X happened because of Y. And now I can carry that relationship and apply to another situation. Oh, I'm seeing Y, so probably X is going to happen again. Even if that instance is very different than everything that I've seen before, I define that relation at the latent space at an abstract level. That enables you to generalize.
Mhm.
It doesn't mean that all generalizations are universally true forever. I mean, look at the Newton's laws. Like it's well, apple falls and then the grapes fall too, a watermelon falls too, and then well, if you actually work that, it's not falling. These are basically attracting each other. Okay, so that's how the planets work. So all of a sudden, we had all this generalization, and without actually having seen thousands of examples, you could calculate how galaxies relate to each other
Yeah.
until we get to the subatomic level,
Yeah.
to the quantum level, and then the generalization broke. So
Mm.
it still is very, very valuable, but it was not just like, well, Moon moves like that, and Saturn moves like that, and Jupiter moves like that. It was a broader commanding relationship. I don't see any other way, if you don't have a way of capturing causality and have a way of explaining causality, to combat all of these just with teleoperation or data. More data is not going to solve everything forever. It can give that impression of now we are doing a little bit better because we were able to memorize a little bit better, but fundamentally it's not gonna solve it. Maybe like a summary of that is, it is like taking acing the SATs versus actually understanding calculus.
Yeah.
You can ace SATs, and as long as the next thing you face is another multiple choice question that you know the type of, you look like a genius. But
Yeah.
if anything outside of that, if you actually have to derive the formula for the volume of the sphere, if you know how integral works, well, you can actually do that. If not, you can't.
Yeah. Yeah. No, that's a really good explanation for this. I think generalization to a certain extent is fine. After that, there are a couple of things that are supposed to be kept in mind related to literally anything. Like you gave the example as well for just, SAT exams and everything.
But
Um,
by the way, like also, I'm not dismissing the value of being able to memorize to a certain extent, because in our day-to-day lives, we also do not consult our generalization and abstract planning abilities. 90 plus percent of the time, we just fetch from the memory. We
yeah.
just do what we've done before and expect it to work the way it worked before. And more often than that, it does.
Mhm.
We only go and take a step back and really use our brain, if you will, when there's an exception. So being able to memorize things, it's also helpful and it's going to play a role. But going beyond that, really unleashing this insane number of robots into the wild requires a more fundamental understanding of the universe, not just memorization.
Yeah. Yeah. Yeah, no, 100%. I think that makes a lot of sense. I think, yeah, there's like a lot of things that are going on in my mind right now. Uh, where I mean, I just have a random technical, not exactly technical, but just a sort of
Mm.
question in my mind. I was recently watching how Figure AI went on a full-fledged like week-long run of like robots, which were, putting the labels and passing it on the conveyor belt. And randomly, this one time in the evening when I looked at their video, that second the robot stopped like running. Like it was unable to flip the box. And it just kept repeating the same process 20 times until it felt like an external like teleoperation person comes in and stops the process and then moves it away so that it replaces with another robot. And the question that arises over here is two questions. One of them is, what do you visualize? Like, how many years down the line do you think that robots will actually be able to act like maybe even, I would say 20% like human beings and maybe actually, deploy itself into the real world and understand situations? And then the second question is, because all of this, like let's say, for example, your robot is already in the real field and
Mhm.
a mistake happens, and if it's at someone else's, like a client's place, or like if it's at my place and the robot messes around, what am I supposed to do in this scenario? Like, we can't have someone come and repair the robot all over again. Like, what are the ways and tricks like the robots would potentially use to fix itself, or, get away from the problem they were facing previously?
Yeah, it is. Well, there are several questions as one. So uh, we can be talking about hardware failures. We can be talking about software failures. And software failures can be actually failures like software crashing, etc. Or its software is working, it's just not capable of interpreting and basically acting on the current situation.
Yeah.
The current state is beyond its comprehension or beyond its capabilities. So all of these actually require different playbooks of dealing with that. The first, the hardware piece. You have to be very mindful from get-go in where and how you make decisions about your hardware choices. I also believe that the big uh, scale-up impact will come from full vertically integrated companies. You have to be doing the hardware, the software, whole nine yards, everything. And for hardware, well, you have to make sure that you are building it as reliable as you can and continuously improving it. B, you have to treat your overall system design almost not as maybe paranoid, but almost at that level of building a Mars rover or building a deep space probe, because you're going to send something and then you will have some telemetry, you will have some connection to it, but assume that you are never going to be able to get physical with that robot.
Yeah.
So you have to design something that you can do a lot of the diagnosis, a lot of the I don't know redundancies, switching, etc., just to keep the system operational remotely. Of course, we are also not building Mars rovers, so we can actually get to the robot. So you don't need to go super ballistic about that, but you should. This should be the front and center of your mind, all the way from component selection and quantifying what could fail to how can you basically take one more component off. It's always about reducing the number of potential failures. The hardware part is all about that. And the software part is software crashing is it's just like better introspection, better testing, better instrumentation. So you first need to understand and have the capability to understand whatever is going on in the system. And then that's the first level. Like as step one, you can just say that I'm going to know everything that's happening in the system, but I won't be able to do anything about it.
Yeah.
But that's a great start. And then you can start developing, well, if A happens, and then this is the playbook. I'm gonna make the device driver self-healing so that if anything crashes, it's gonna figure it out, look at the diagnostic and restart itself and ping the mothership so that someone pays attention to it, etc., etc. The uh, hardest part is when everything is fine and operational, there's no hardware failure, there's no crashing software, but you see a situation you cannot handle. That's the piece where you just have to get smarter. You just have to understand the world better, maybe sense the world better. If your level of information is not enough, maybe have better sensors, better processing, less noise. If the data is fine, but you don't know what to do with that, better algorithm, better generalization, better abstraction, better memorization. When it's so, it is basically the very long and very fat tail of continuous improvement. We talked about that. We don't know what we don't know. To combat that, the only thing you can do is to be ready for that future improvements. You need to have the right instrumentation, and your system should be designed from day zero for ingesting new information and being able to self-improve with that.
Yeah. Yeah. I think coming from like mechanical engineering background, like hardware is one of the most important things in any part of like robotics in general as well. I think the way you can incorporate like 20 sensors in a span of like 3 by 3 radius and make sure like nothing of that messes up, and then you are converting that into like real world signals is a very important task. And there are a lot of considerations which are taken while making such a sort of a product, which actually makes me question one more thing. Like, okay, now the world of tactile sensors are coming in. And for the last, I would say,
Mm.
like 5 to 7 years, no one, I mean, probably like 95% of the companies did not incorporate a tactile sensor, right? And all of a sudden, there's this new wave like, oh, we need like different motors, we need different sensors. And so the question I have for you is, all of a sudden, when you are introduced to a tactile sensor and your robot is already full-fledged made, everything is done.
Mm.
How would you incorporate that tactile sensor onto, I would say fingertips. Let's start off with that. Fingertips, tactile sensors. And then do you retake all the data, or do you just do sensor specific? And then how do you test it? Is it like a whole loop starting all over again, or is it like just an add-on, even the hardware and the software part?
It depends on how you started your hardware and software architecture. Again, it goes back to like memorization versus understanding, and how much you have been memorizing and how much you've been abstracting and understanding. If you have been abstracting and understanding to a certain extent, then this is another input.
Mhm.
However, that is a very important input, especially for dexterous manipulation. So
Yeah.
it always fascinates me that one of the top examples people give for humanoids particularly, that one of the earliest tasks that they think humanoids will be able to do and make a difference is installing wiring harnesses in automotive factories, which if you've actually seen any automotive factory and wire harnesses being inserted, more often than not, there is no line of sight with that. Someone grabs the wiring harness and goes in under the trunk and under the hood, and just by sensing, you grab a connector and then you have your plug, and then you mix and match, and then you feel a click. And then if you're not, you're just like with your fingertips, you are trying to make, because you know kind of sort of how the connector looks like. So you're trying to localize
Yeah.
there. And you, of course, humans can do that, especially trained humans can do that in a couple of seconds. This is maybe not impossible, but exponentially more challenging to do without proper tactile sensing, and not just the existence of the sensing.
Yeah.
If you are not geared up to consume that information at a very fundamental level, then it's just going to be a band-aid. So I think if you build a full robot with no tactile sensing, and then boom, you wake up one Monday and then tactile sensing is there,
Mhm.
you will have to redesign.
Yeah.
And that's not a bad thing. It's also another philosophy that you should always be prepared for having a big impact like that, because if you are facing the two options that, well, there's something that can make my system substantially better, but it will require me to almost do a do-over, or
Mhm.
at least like throw away a lot of the hard work, blood, sweat, and tears, and just like not start over, but like a significant new pieces of work, versus I already designed my system. I'm gonna stick to that. I know how to build it, and I'm not gonna benefit from this new, very very informative source of uh, signal.
Yeah.
To me, again, like, yeah, you will be prepared to use whatever becomes available,
Mhm.
and you will set up your system at the abstract enough level with understanding and with causality and with future provisions for, even if today we don't have smell, we don't have tactile, we don't have this, that, you should build a system that if that becomes available at some point, you can basically plug that in and incorporate without a complete do-over, even though it will always be a substantial amount of work.
Yeah. 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 All factory sensors are still yet to be there on robots.
Yeah,
Cool.
most industrial tasks, they don't seem to be like critical, but at the same time, well, if you are shorting something without knowing that there's a smell that usually comes to you first,
Yeah.
which could be the difference between a fire and a timely mitigation.
Yeah. 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 I think it's a smart decision to know that there is a lot of future scope. And if we are going with this V1 version of our humanoid robot for the next 5 years, anything can change. And on that basis, you design the robot the way you want to.
Well,
But yeah, I
I
think,
mean, here's another prediction, unsolicited prediction maybe, but I think in 3 to 5 years, I think we will see a significant amount of truly intelligent and dexterous robots in our lives, in
yeah,
the different industries. But I don't think many of them will not be of the traditional humanoid form with two legs and two arms.
yeah, yeah. I have been reading, people have been questioning why do robots only need 5 fingers? Why not six? Is it a norm that it is supposed to have only five? It really depends on the use case, obviously. Maybe 3 fingers can do the job. Uh,
Three fingers can actually do about 80-90% of everything that you want, and with four
yeah.
fingers and not as many joints either. For somewhat compliant fingers, you can actually do everything a five-finger hand can do. And if you can have four fingers instead of five, you should have, because that's less things to
Yeah.
fail. Again, going back to reliability.
Exactly. I think that's where the world is slightly moving a little bit towards now, moving away from like real looking humanoids to something which is like more usable, more convenient, and requires a lesser amount of like hardware knowledge, not knowledge, like hardware amount of hardware, just sensors and
I
other things on there.
Yeah, I think, I mean, there's of course some emotional part of that too. People get excited by the idea of true human replicas also being intelligent, etc. But most of the times people tend to confuse form and function.
Yeah.
What we need is the same dexterity, same flexibility, same world understanding. Actually, superior than even humans, like the superior dexterity, superior agility, superior world understanding. But it doesn't have to. We don't have to trap that super intelligence into the same form factor. We look like, however, we look like not as a result of, well, this is the only way or this is the most optimal form factor. It's just like this was enough for us to survive. That's why we have that. And if you look at the history of humankind, the history of civilization, all humans did throughout the history was to replace humanoids, which are themselves, with non-humanoids, which are all the tools that we invented. We built the tractor, we built the steam engine, and we built the plane. None of them are humanoids.
Yeah, yeah. I think form factor and the usability of things is more
Yeah, if you say, like, for instance, if you say things like that, well, I have all this, I don't know, excavators and dump trucks and all this industrial machinery, and you really need to look like, and you need to form factor of a human to climb in and drive those. Like, that's a very rare requirement that actually imposes a certain form factor. But for most other things, for instance, you don't need two legs for
yeah,
almost anything.
yeah, yeah. Yeah, 100%. I think that makes a lot of sense. I think form factor is important. You should know exactly what use case is your robot actually going to be working on. I think that brings me to like, one of the last questions before we move into what you would like to give to the community. But um, the question is, robotics is getting big. Everyone knows that. Sensors are coming in, coming out, people are using it, form factor, everything. All the conversation we have had so far compiled into everything leads us to one question. The future is definitely changing, and people are
Mhm.
moving into industries which have been untouched. Some of the
Mhm.
industries are agricultural robotics. One of them is building architectural robotics as well. You know, um, a YC company got funded for building robots for Mars.
Mhm.
And
Mhm. Mhm.
I was reading about that recently. And people are moving into like different like unknowing scenarios where like if you actually dive in, the industry is actually very big because you would want to reduce you know the safety concerns by deploying robots. Maybe you can make the job easier for a lot of human beings. And blue collar jobs are becoming increasingly hard, and people are deploying robots to make them easier. What do you personally think? Like, what is the scope of architectural robotics, like, buildings and stuff, and ag tech, and also this completely new idea of building robots on Mars?
It's not that new of an idea. That has been like building interplanetary robots, robots to operate on moon, robots to go to Mars, etc. Robots that actually have gone to Mars. There are robots on the Mars right now than there had been for the past 40 years almost.
Mhm.
So it's not a new idea. I think it all comes down to first starting with asking this very basic question of how is that relevant? So why are we doing that? Is that a commercially relevant activity? That can we create commercial value to someone so that they can pay us more than what it costs us to build that robot and send it to Mars? If that's yes, well, have at it. If that, as long as the answer to that question is yes, that's your next market. You can go and do that. And then, of course, the subsequent questions are, well, how much you can actually charge for it, how much you can actually make it for. Like, can you can you create a basic diagram where you are creating a certain amount of value. You
Mhm.
are asking for a little bit less than that value, so that the difference is the value proposition to the customer.
Mhm.
And your cost is a little bit less than what you are charging for, and the difference there is your margins. So as long as those simple equations hold,
Mhm.
everything is ripe for robotic disruption.
Mhm.
The technical viability, can you do that, is another thing. Sometimes if it's national security, for instance, then the cost is not very important. Or sometimes it's just for the sheer uh, sake of intellectual curiosity. I mean, we didn't send robots to Mars before because there was money to be made. In fact, they were pretty expensive programs. We sent it because we are curious by nature and we wanted to know. So
Mhm.
you need to understand, like, why are you doing that, and like what's the audience and what's the purpose, and use that as the biggest filter. That applies to architecture or construction. That applies to agriculture. Agricultural robots, they are agriculture. You have to first solve the business model problem before you can move to solving the technical problem. I
Yeah.
think we make a lot of progress in technology, and we've made a lot of progress, and I'm sure the progress will continue. More often than not, the failures are not around the technology piece not being figured out. It's basically starting with the wrong industry or the wrong use case or the wrong business model. If you can lock in the fundamentals first and establish a good enough North Star,
Yeah.
so that you can lock your eyes on and just go through the storms, but you know that fundamentally you're on the right path. You can basically, as long as you can reduce it to just technology, more often than not, you can crack that piece.
Yeah. Yeah.
So I think all of those industries, we will see some examples, but I think what separates success from maybe not failure, but the lack of success, which is like a different state. This
Yeah.
endless pilots, or like seemingly something is happening, but the big adoption is never coming, and everybody's wondering why, because things seem to be working, etc. In all of these situations, when you dig deep enough, you realize that that's actually a manifestation of crossing the chasm.
Mhm.
Every technology starts with early adopters who are a lot more benevolent, a lot more tolerant, a lot more, like they have either disposable income or they are just like into new things, so they are happy to spend some money on it without necessarily expecting a return. But as you move forward, at some point you face the boss, and the boss is always pragmatic users. They
Yeah.
are they are not the ones buying Tesla Roadster as their fifth car and they live in Malibu, but they are the ones in like living in Milwaukee or Michigan, and if they buy an electric car, it's going to be the only car of the family, and that needs to withstand negative Fahrenheit for months, and the battery should not die. So you realize that, well, this is where the actual value is. If you want to actually succeed, you got to solve the problems of, you got to appeal to the pragmatic users. What are the pragmatic users of robotics? As you move forward, you will learn that. But almost always, you have to basically offer a value that means you are better than their today's baseline.
Yeah. Yeah.
And if you lock in there, then I think you will see a lot of traction. And if not, it's going to be more pilots
Yeah.
somewhere.
Yeah. Yeah. No, that's a very good detailed explanation of how exactly are you supposed to approach a problem, and how do you exactly know you are in the, obviously customer validation is the most important. You need to understand the scope of problem first before actually diving deeper into it. And third one is also you need to know whether this market is friendly enough to give you the returns for what you are making, and is it actually a buildable market on this. Like, we know that there are a lot of industries which are untouched, and they might be untouched for a reason, or maybe someone has not maybe figured out a way out of it, you know?
There's always a reason.
Yeah, exactly.
So
So
yeah, there's a little bit of a meta lesson here if we tie everything to the same thing. You have to be asking the why question.
Yeah.
Just like robots need to understand and not memorize, we need to also understand why things happen the way they happen, and not just what, and doing more of the same. If 50 other companies are just throwing more data at bigger models, being the 51st one doing the same, you
Yeah.
just assume that you are going to be able to get more data and throw out more compute because you're going to be able to raise more venture capital, is rarely, if ever, the answer. If you ask these questions of like why people buy or why people don't buy, why and how value is actually created and exchanged, if you spend enough time at the abstract level of truly understanding an industry, truly understanding the business, truly understanding the technology, why something fails, why something not, why something works. The why arguably is the most important word ever
Hmm.
existed. And as long as you are being a good student of why, you have a chance of figuring things out.
Yeah. Yeah.
That's the meta lesson.
Yep. Just I know we so just coming to conclusion right now. Um Before we end this podcast, one last question is, what do
Mm.
you think if someone is starting off in the robotics industry for the first time today? What are some of the things you are supposed to keep in mind, be it a hardware engineer or a software engineer, anyone who is, just trying to learn robotics in general? Some, I would say research papers, articles, books, online resources, or 3D printer to just print and figure it
Well, all of the above. Like you have to suffer, right? There's
out.
no pain, no gain. You have to suffer, but you have to enjoy suffering too. This is like going to the gym and working out. You're clearly doing things that no one is forcing you to do, and you're in pain because of that. But you also feel good because that gives you some gains towards the goal that you are going to find. So my like uh, abstract level or evergreen and overarching advice is to be curious. This goes back to the why question again, but to be curious about almost everything, and to be obsessed and fascinated by problem solving, not solution probleming. Whatever you think you have as a solution, or you have an idea or something, do not treat it as a hammer and then everything else as nails. Truly understand, do that emotional work and intellectual work in relating to people, and truly understanding, be in their shoes, and what moves the needle for them, what problems do they have, what fears do they have, if they resist to new technology, or your why. One of the things that I see the most is, especially coming from high technology people, looking at industries like agriculture, construction, or logistics. These are archaic industries, dirty and not technology forward.
Yeah.
People think that the operators in those industries must also be stupid and not knowledgeable, and like they don't know what they are doing. This could not be more false. I have never seen anyone that's not smart, that's not truly like wanting to do their job better. And not I haven't seen anyone who wasn't as passionate as the next guy.
Yeah.
Really, like taking that 30 seconds and trying to understand, asking why instead of shaming them or instead of passing judgment, really trying to understand, why are you doing this seemingly inefficient thing? Is there a reason? You will be surprised, more often than not there is a reason, and that question leads to other questions, and before you know it, you start understanding the problem better. It's all about, we are now all of us are interacting with these AI models, and we are now all realizing, oh, context is everything. So a model, regardless of its sheer raw muscle power and capabilities, it is only as good as the context that it has. Well,
Yeah.
guess what? We are like that too. Our decisions, regardless of the technical or business brilliance, our decisions are only as good as the context we have, because we are making those decisions in a universe. So try to expand that.
Yeah.
That's the best thing you can do. Be curious about, if you are a hardware person, be curious about software too. Be curious about different parts of software. If you are a software person, be curious about hardware. Be curious about business. Why? we are doing what we are doing. Like, what happens if we don't do that? Does it really need to happen? So ask all of those questions. There is no harm that can ever come from asking why questions. And the
Yeah.
more you ask, the more you learn. The more you learn, the more context you have, the more context you have, just a tiny bit better chance of you getting the next decision right. And it's this whole compounding factor. You
Yeah.
will get a lot of decisions wrong, but occasional decisions, getting them right, will compound. And all of us as a field, not just individual companies, that's how we will move forward.
Yeah, yeah. It's all about how you perceive a situation and learn accordingly. It's not about how you just know about something and you just assume that you know everything about it, because the why question still remains and you are always gonna have the same issue again and again. I think that was a very resourceful talk in general.
Thanks
Chetan,
so much.
I myself actually got to learn a lot lot more.
I'm glad. I'm glad. Thank you very
Uh,
much.
yeah, and hopefully whoever is watching this podcast gets to understand and maybe execute all of these things in the real world, and hopefully, form a sort of community of more roboticists in the world, hopefully all over the world. But yeah, but thank you so much, Chetan. It was great talking to you, and hopefully.
Fantastic. Yeah, thanks for having me. And yeah, like the future is bright. It has challenges, but the more we ask, the more we talk, the more we brainstorm, better the chances of figuring things out.
Yeah.
So yeah, I'm open to discussions, and I'm always down for brainstorming and figuring things out together in the field. So I invite everybody to reach out.
Yeah. Thank you so much, Chetan.
Of course, thanks so much.